How's everybody doing today? This is Dr. Winkler. We're still working on with History 151G. I believe this should be our 7th lecture. Today we'll be talking about the scientific revolution, and we'll also be talking about the Enlightenment. We were talking last time about science and how this changes people's ideas as far as the nature of the universe is concerned, the nature of cause and effect. We're talking about Copernicus. Let me just review just a little bit here. Remember Copernicus. He's a Polish astronomer. And he essentially argues that if you look at the phenomena out there, there's more than one way to explain it. We don't have to follow Aristotle. In reality, we can look at it differently. And rather than having the Earth in the center of the universe, we can put the sun and have the Earth going around the sun. This leads to the Copernican revolution. Because when people look at this and say, there's a different way we can possibly think of this, then they also start looking in other directions. We don't have to go to the old authorities. We don't have to go to Aristotle to get a very good view of what the world is actually like. We do need to have something of a scientific methodology. And that's what I want to turn to right now, the man by the name of Francis Bacon. Let's see if we can get a portrait of him for you. I mentioned to you last time a little bit about him. Kind of a rogue a little bit, politician in England. As I mentioned, he's an Englishman. Well, he makes contributions in several areas. However, when we're thinking about science, we're thinking largely in terms of scientific methodology when we talk about him. And let's look at the kinds of arguments he's making. One of which I mentioned last time is the inductive method. Let's take another shot at Aristotle. He's an easy target. We'll hit him a few times. One of the things we're looking at is the idea of Greek epistemology. How do you know things? Many Greeks, ancient Greeks, believe this, that we actually have all knowledge up here. The world is a mind game. It is actually intellectually found within our mind. What we have to do to find out what's going on is to understand better what's already in our mind. We will have created a logical explanation, a logical universe from our mind. So when he starts out with his theories, everything is perfectly round, perfectly spherical, the Earth is round, the orbits around the Earth are round. And when you have information that doesn't fit neatly, you just make another little loop. Remember, I mentioned this last time, another loop on the orbit of Jupiter and Mars and Saturn for that matter, in order to make it fit. So that's a deductive method. You start out with your theory and you look in the opposite direction and make all your data fit within that theory. Inductive method is what Francis Bacon wants. Francis Bacon wants the inductive method. He wants to infer from the particulars. In other words, we look out of all this data. And from all of this data, we can now come back to a coherent theory. One of the issues, of course, is you have to be very, very careful about your data. Let's take a look at that a little bit, your data. I have for your viewing pleasure a hand grenade. You can see it's hollow. There's nothing in there. This is not an explosive device. This is a shell. I bought it at a gun show. It's like, would life be complete unless I had a hand grenade? Well, of course not. It's just totally a dummy. In any event, let's say we have this hand grenade, and I'm not going to make a silly statement about let's explode it, which obviously we cannot do. Nonetheless, let's say we're just tossing this around. Well, I've been doing this kind of thing ever since I was a kid. In fact, I was a baseball player, and you throw the ball up and it always comes down. It always comes down. So let's see, what are we doing here? You go like this, and you say, how many times do I have to prove that? That every time I throw something up, it will come down. I've done this, what, 5 times? Let's do it 6. Wow. Do I have evidence? Yes, I have evidence. Do I have proof? How many times am I going to have to drop this and have it fall in order to demonstrate that it will always fall? Not 5 times, not 10 times, 100 times, 1,000 times, multiple thousands of times. If you get enough data, then you can say, oh, by the way, this is probably a principle. What if I did this? I know it won't happen, but what if theoretically this happened? That I threw it up one time, and maybe I've done this 1,000 times. I threw this up one time and it didn't come down. Or it didn't fall directly down, it fell to the side. Well, what do? I say, well, see, I had 1,000 times where I've demonstrated this. But there's one time it doesn't work. This is called the negative instance. The negative instance essentially says this, that even though you have a considerable amount of data to demonstrate one thing, in reality, if something does not fit, you're going to have to reevaluate everything you've done. The overwhelming amount of data does not negate the fact that it doesn't work all the time. So the negative instance can invalidate what you're doing. We have to be very careful about cause and effect. When things are found together, shall we say found together very often, if not all the time, then obviously there's a connection. Well, you have to be very careful about that kind of thing. The example I like to use is birds and trees. Have you ever seen birds in trees? Yeah, I've seen birds in trees. Very often that's usually where they hang out. The cats can't get them up there. So we always see birds and trees together. The question we have to ask ourselves is this. If birds and trees are always found together, which is it? Do trees come from birds or do birds come from trees? Now wait, you and I both know that either one of those postulates is incorrect. But they are found together virtually all the time. So we have to be very, very careful about cause and effect. That in reality, there might be other things at play. Once again, we're talking about a great deal of care. I like one of the stories that Francis Bacon told about going out and observing. You know, don't look back at Aristotle. Don't go back and look at other authorities like the Bible as your only way of understanding something. So he actually came up with a hypothetical. There are a bunch of scholars, and the scholars are sitting around and they're discussing how many teeth are there in a horse's mouth. Well, how do you find out? Well, let's read the Bible. It's not in the Bible. Let's read Aristotle. Let's read Galen. Let's read other classical writers and see if it's there. They can't find it. A young scholar who really doesn't know what's going on, why these old oafs are quite foolish, he comes into the room and he says, oh, by the way, why don't we just look in a horse's mouth and count? This is so absurd. This is so ridiculous. These old scholars take this kid, beat him up, and throw him out. And what's your conclusion? Their conclusion is this. The number of teeth in a horse's mouth is unknown and unknowable because they can't find it in the old sources. Obviously, Francis Bacon is saying this. Let's look for ourselves and see what we can find out in that respect. He wrote a novel, as you can see, published at about the time when he died. It's called The New Atlantis. I'm sure a lot of you are familiar with the theory of Atlantis. It goes way, way back. Even reading in Plato, he said there was an island. And the difficulty is we don't know exactly where he said it was at. It could have been in the Aegean, if we interpret his numbers in a certain manner, or it could have been way out in the North Atlantic. Well, we do know, for example, there was an island called Thera. Oh, what was it, about 1200 BC? It blew up. This volcanic island, just boom. And you can go back. Shall I be silly here and show you a map of Thera? And Thera, how about an image? If you look at it, as you can see from above, it looks like the mouth of a volcano. Some kind of enormous explosion right here devastated this island. Could Plato have been talking about this? that there was an explosion, this land was lost. You could have. But some people want to say that it was actually out in the Atlantic. Over time, the theory of Atlantis has, I would call it the myth of Atlantis, anyway, has developed considerably over time. Now it was a continent. This continent was in the North Atlantic, and it's highly advanced technically, and it sunk down. Sometimes we've even had cartoon movies talking about people that did live on Atlantis, that when it sunk, they somehow grew fins and could breathe water and they can swim around. All this is really good fiction. Can we say that Francis Bacon does contribute to that kind of ideology about the New Atlantis, about Atlantis? In his book, The New Atlantis. And it is a novel, there's a plot involved. But he actually is talking about how science can influence technology. Now, he's quite right in this, is he not? That science will, as you and I know, we have theoretical science. But when we explore how, like, electricity works, we can harness that knowledge to make wonderful electrical things for us, including computers and smartphones. But his insight for the time frame he wrote this is remarkable. He envisioned a world, actually he's on an island, the plot takes place on an island. He envisions a world in which technology serves us. It serves humanity. It does work for us. By implication, he says that technology can make carts move by themselves. That's an extraordinary insight, because his time frame, the only way you move a cart is with an animal or a human being. Of course, you and I know with the internal combustion engine, electric motors, those kind of things, that there are internal capacities scientifically that will allow things to move. Can we say the idea of the promise of technology is something that he actually brings forward? And this is an impressive thing. Well, let's take a look at some other people, shall we say, that are working in about the same direction at about the same time. There is a Frenchman, it's a Frenchman now, by the name of René Descartes. He is a philosopher, he's a scientific theorist, among other things. Take a look at Descartes. Descartes believes that reality, that matter is always in motion. Even though, shouldn't use his hand grenade too often, even though his hand grenade feels to be quite heavy. In fact, the particles, whatever's within it at a very small level, is in fact in motion. He goes so far as to say a clock, which is, can we say, in the 17th century, the 1600s, is probably the most advanced technology out there. I would say that. I mean, it's remarkable what they're doing with clocks. It's remarkable how you can have it tell time. And of course, clocks really hit in a big, big way during the Middle Ages. And they've advanced considerably since that time frame, where they get even more impressive because they can do more things. And in other words, they can tell the time of the day, tell the phases of the moon, the days of the week. Sometimes they'll chime out the days, the time of day. And as time progresses, they get into smaller and smaller packages. The universe reality is like a clockwork. A clock is a device that tells time. A tree is also a mechanism, but the size of the parts are ever so much smaller. While a clock tells time, a tree produces fruit. So he's trying to get a better understanding as to the physical function of the universe. And his insights are very clever. He takes a step a little bit farther than Francis Bacon. Yes, Francis Bacon, his story says, you got to look in a horse's mouth to see how many teeth there are in there. Descartes went a little bit farther. He actually said we should start with doubt. We should doubt everything. We should doubt everything that we know, that we think we know, and literally start over again and think anew. He goes far enough to even suggest that we should actually doubt our own existence. I don't quite go that far. To a certain extent, I think it's self-evident that I exist. I could be perfectly fooled. Of course, one of my sci-fi friends pointed out to me, he says, yeah, you think you exist, right? How do you know you're not a brain in a jar on Mars? And everything is a construct by how often they put an electrode and stimulate your brain. Well, I'm quite sure that's not the case, but it can be very difficult to disprove that. Anyway, let's quit being silly and go back to Descartes. We need to doubt everything. That means we need to take a construct to create our ideas of the world. Now, we're going to doubt our very existence. So let's start and figure out if there's a way that we can actually demonstrate we exist. His phrase, this is Latin, of course, cogito, I think, ergo, therefore, sum I am. I think, therefore, I am. Okay, now he's got proof of existence. But wait, people come back and say, oh, by the way, Descartes, what if you're mistaken? And Descartes said, well, I'd still have to exist to be mistaken. All right. Can we say that even though this is a very clever idea, in reality, if you're trying to make a construct, you do have to actually start up with information. You can't sit and debate the question of my existence for a lengthy period of time, because that doesn't really get you very far. So when Descartes starts to examine the real world, he does end up making some kinds of suppositions. Nonetheless, the rigor in doubting, the rigor in asking the important questions is extremely important to help us understand the world, at least from a scientific standpoint. Well, let's take a look at Galileo. Galileo Galilei. We usually just call him Galileo. We've been talking largely about theorists at this time frame, and I'm going to argue strongly that Galileo is also a scientific theorist. However, he does do a lot of important observations, and he makes a lot of important experiments, which do have a tendency to start pushing, shall we say, more strongly back the frontiers of knowledge. Now, I'm not going to say that during the lifetime of Francis Bacon, there weren't people doing real science and observation and experimentation. But I am going to say that Galileo makes a big impression, a bigger mark. These are famous portraits of him that do make a big deal of difference. Well, he's interested in a lot of areas that you and I are interested for this discussion: mathematics, physics, and astronomy. He has a very keen insight, which I've always been impressed with. And he talks about, how do you prove something scientifically? Well, we got Bacon up here with scads of information. Yes, to prove something. Yes, very helpful. Galileo actually says this, that you have to understand the language of science before it makes sense. And the language of science is mathematics. If you do not have the mathematical equation, if you do not have the symbols, the circles, the graphs, how do you put your data in such a manner to where it's understandable? That's a keen insight. Do we ever do this? Remember when I was taking high school algebra, we would graph this. Okay? Among things, we would take our information. This is how you make a graph. This is how you pin on a graph. And this is how you demonstrate certain things. My only trouble with straight mathematics like algebra is that, well, when you threw x equals y, that's very nice if that is your kind of thing. When you actually use it on something that is more demonstrable, like physics, I found that a lot more interesting. Because then the numbers, or the letters in some cases, actually do mean something. But the language is mathematics. It's a keen insight, and we're still using this today. When you read in the newspaper, it might be an issue about unemployment, it might be an issue about the economy, interest rates. You see numbers. And if you're looking at numbers over time, you see them graphs. And if you're explaining something scientifically, you very often have a formula. You have a statement. Like E equal mc squared is the most famous of them all, where you have numbers, in this case letters and number, to demonstrate a principle. Very keen insight. Well, he does a lot of interesting. These guys are really a lot of fun. The story goes that he was sitting in church one day, and at that time frame, it's difficult to light the interior of buildings. There are no such things as electric lights, so it tends to use candles. Well, you can have candles around on candlesticks. Sometimes these can be quite large, but you can also have candles being brought down from the ceiling. Of course, the ceiling can be very, very high. And so you're down here and you have a ring of candles, which helps to illuminate the floor a little bit better, so you can see it better in the building. Well, I guess the meeting was boring, and in any event, he looks up at this and he looks at these chandeliers that's hanging from the ceiling, and he noticed ever so slightly that they're swaying. What would cause them to sway? Well, possibly a little breeze or something. And I would look up and go, "Oh, the thing's swaying." Well, he's a scientist, a lot better than I've ever been. And he looks up there and says, "I wonder if there's a relationship between the length of the cord, the weight of the chandelier, and how long it takes to go back and forth." According to the theory, the only timing device he had was his pulse. So he kind of counted his pulse as it very gently sways. Well, when the meeting's over, he sets up experiments. He uses what you and I call pendulums. You simply have pendulums are usually rigid. They're not usually cords like he was originally observing. They're rigid, and he'd swing them back and forth, have a weight at the bottom, and he would notice a timing property. It's very important. He noticed that there's a timing property in pendulums. By the length of the pendulum, the amount of weight, where it's at, how widely it swings, it can actually sweep out a certain length of distance, in this case, in a certain length of time. Clocks really don't do this anymore because we're using electric clocks. If you have, we have one in the living room, a little bitty old clock. It has a pendulum on it. It's kind of fun. It goes tick tock, tick tock. Reason for that is with the pendulum, when pendulum swings to one side, there's a gear and it releases the gear. Tick. When it comes back, it releases the gear. Tock. So when you have these kinds of things using the pendulum and a gear, you can see the timing property of pendulums. Now, he doesn't invent the pendulum clock, but he argues for the principle for this. One of the most famous things he did was his experimentation on falling bodies. Let's get some falling bodies up here. Okay, famous experiment. We don't know if it took place or not, because when he was writing about this, he was talking about if a person, he didn't say he did this, he didn't say he didn't do this. If you walked up to the Leaning Tower of Pisa, Leaning Tower is still there. It's a wonderful tourist trap place. People want to see the Leaning Tower. Of course, the Italian officials are always worried about, is it going to lean too far and fall down, or we don't want to have it too straight, then the tourists don't come to see a straight tower, they want to see a leaning tower. Any event, the question he asked himself was this: what would happen if you dropped two objects? Let's be kind of silly. I'm a silly man. This hand grenade is, I don't know, weighs probably a pound or two, a couple pounds, and I have a pen which weighs probably a few ounces. And this one's a lot heavier. Let's just really exaggerate. Let's say this thing weighed 10 pounds. It clearly does not. But let's say it weighed 10 pounds and this weighed 1 pound. And I'm standing up 10 feet above the ground. I go like this. And I drop them both. Now, according to Aristotle, this one's obviously heavier. It's obviously heavier. Therefore, it will fall faster. Why? Well, you thought about it, right? Heavier things will fall faster. It makes perfect sense to him. Quite frankly, logically, it makes perfect sense to me, but it's not how the universe functions. According to Aristotle, if you went out and dropped these things, 1 pound and 10 pounds, not only would this one fall faster than this one, but since it's 10 times heavier, it would fall 10 times faster. In other words, we drop these things from 10 feet. This object would hit the ground, pop, before this had gone more than a foot. Now, how easy would it be to demonstrate that that's in error? As far as we know, nobody in 2,000 years had ever done that experiment until Galileo did. Now, one of the reasons why Galileo might have done this once, but one of the reasons why historians tend to doubt this is, could you imagine how challenging this would be? Now, you'd have to be in great shape because you got to go up a lot of stairs to get to the top of these things. And then when you drop 2 weights right here, you're up at the top, or you can have an assistant up there. He or she can drop these things. And then here they come, as you know from your physics, they accelerate, they get going fairly fast. You go, how carefully did I see that? So actually his experimentation was not walking up and down the Leaning Tower of Pisa, though he might have done it once or twice. It was actually using inclines. You have boards laid down, and your objects are round, and you have a heavy object and a light object, and you release these at the same time. He's arguing, even though there's clearly friction in the board, that will slow down the process. It is still the same thing as if you were dropping them in air. So with numerous examples of experimentation, heavy objects, light objects, he rolls them down over and over again because friction slows down the process. In reality, he can see what's happening. If you drop it in air, sometimes it's just too fast. He demonstrates over and over and over again that it does not matter the mass or the weight of an object. What does matter is that they're falling at the same time. That's not Aristotle, that's not logical, but that is how the universe works. Of course, you could drop a feather. You've done this, I'm sure. You take a feather, you drop it, it doesn't go, it goes, Galileo realizes, obviously, you drop a rock, you drop a feather, the feather does fall much more slowly. The reason he argues is this, that obviously air, or the resistance of air, slows down the feather. Therefore, theoretically, if you were in a vacuum where there was no air at all, you could actually drop these at the same time. Say a hammer and a feather at the same time, and they both hit the ground at the same time. Now, we can't create a perfect vacuum on the Earth. You really, when you try to pump air out of a room, for example, there's always going to be some left over. You can have it pretty bad in there, small amount of air, but you're always going to have some air. Well, a perfect vacuum exists on the moon. There's no air up there at all. Well, I come from an interesting generation. I'm so old I can remember when we didn't even have satellites into space. And people were saying, oh, I don't think human beings can survive up there. Well, obviously, a lot has changed since that time frame. Yes, I remember the moon landings. Oh, what a thrill. Been looking forward to that my entire life. Moon landings. And there were several, as you know. I believe the first one is 1969. The last one was 1972. The last time we went to the moon. It was not in the first mission, but it was essentially on one of the later missions. We have an astronaut. He's in his spacesuit, standing on the moon, and he has a hammer in one hand and a feather in the other. And he's trying to demonstrate what Galileo was talking about. He said, let's do that experiment. I'm glued to the television going. You see, I always believed that Galileo was correct. I always believed. But on the other hand, I'd still like to see this, right? So in any event, the astronaut, he apologized. I'm not sure I can drop these exactly at the same time. Well, okay. He holds the hammer in one hand, he holds the feather in the other hand, and he did a good job. He dropped them at the same time. And just like two rocks, they went straight to the ground. Yes, thank you, Galileo. You're correct. Let's take a look at the astronomical telescope. Galileo did not invent the telescope. There was a Dutchman, was his name Leperche, who invented the telescope. I find this very remarkable. For literally hundreds of years, people were, well, actually been aware that light, that glass bends light for a very lengthy period of time, even much earlier than that. I like the Middle Ages. I like to, when I get the opportunity, I like to hang out in medieval castles. I like to hang out in medieval churches, Gothic cathedrals. Because sometimes the glass in the windows, for example, can be hundreds of years old, can be very old. And a lot of times what they were doing at this time frame, the way they made a pan of glass was you would melt the glass, the sand and the silicon, and you would blow a bubble, good lungs, blow a bubble with it, and then you would spin that. This is liquid glass. You would spin that till it flattened out, and then you got a pan of glass. But they didn't have the ability to make these like modern glass is. That is perfect. So you kind of see little spirals in it, looking through these windows. And of course, when there's more density in glass in one place than another, you look over and you can see, quite honestly, that there is distorting light. In the late Middle Ages, we think the first pair of eyeglasses was actually invented late in the 1200s, late in the 13th century. Probably in Salerno. Unfortunately, we do not have the name of the person who invented this. But starting that time frame, I got my glasses here, my reading glasses. I read an article about people in Germany. If you wear glasses in Germany, you're smarter, you're an intellectual, you're a professor. So, according to this article, a lot of people in Germany wear glasses, they don't need them because it makes you look more intelligent. Well, I need these to read. They are quite helpful. Nonetheless, you've had eyeglasses around for a long time. And if you have convex and concave, you know what that means. These kind of glasses. And so initially you have reading glasses, and I think that's for people that are, reading glasses are for people that are farsighted. And when you're looking outside, you have different kind of glasses for people that are nearsighted, different kinds of lenses. This has been around for a very lengthy period of time. All a telescope is a concave and convex lens. You got one in each hand, you go like that. And if I can line this up properly, you have got a telescope. But apparently nobody had done this until about 1608, when a spectacle maker was playing around and noticed things are bigger. Galileo had not even seen one of these devices, but he'd read about them. This is a principle that he understood, having read about them. So he took it upon himself to make one of these devices. Grinding a lens back then took a lot of skill, actually. I believe his telescopes actually, or one or two of them, actually still exists. Well, let's give you either an artistic representation. Yeah, it's just essentially, you know what a telescope is, simple telescope. It's a tube with lenses on it. That's really what it is. And he ground these by hand. To me, that's quite remarkable. You grind these by hand. You got glass, and you got I don't know, you got some kind of sandpaper. I was told that sometimes people making lenses back then would actually count the number of times in which angle that they would grind the lens to make sure it's completely accurate. Obviously, this would take a lot of skill. And one thing you don't want to do is have a lot of streaks, a lot of ridges in your glass that's going to distort the image. Well, this would take some time if you're careful enough. you do come up with a telescope. Now, he's living in Venice at this time frame. Venice is in the eastern part of Italy, at the top of the Adriatic. If you have a telescope, it has some practical application. There are towers in Venice, then as now. And if you get on top of a tower, do I have an example here? Apparently this is a tower. You can look across the sea. Since Venice is a commercial center, they send a lot of ships out for trade and commerce. If you're up at the top of this tower with a telescope, you can see a ship at a long, farther distance than actually if you're up there without one, through your naked eye. So this is very, very interesting. However, it really gets interesting about 1610. Yes, he probably has his telescopes in 1609. But in 1610, he turns the telescope to the sky. They don't have nearly the problems back then as you and I do with light pollution. I mean, you walk outside and you can't see anything because the street lights and everything's on. As an amateur astronomy guy, I haven't done this for a long time, but I used to get the old telescope, stick in the back seat of the car, drive out in the desert where you don't have light pollution. Well, he doesn't have that problem. Oh, it's so fun. And he plays around. Looks at stars. Well, you can look at a star and you get a larger image of the star. But it becomes extremely fascinating when he looks at Jupiter, for example. Well, you look at Mars, and Mars kind of looks a little pinkish, the red planet, and you look at through a telescope, it looks a little bit larger. And not really change anything. But it is remarkable when Galileo looks at Jupiter. Let's see if we can get a representation of that. Well, we got Jupiter, thank you. And Galileo is the spacecraft. Okay. So any event, let me tell you what happens. He looks up there and he sees Jupiter. And he notices on either side of it, there are little stars. Now, I've watched Jupiter enough that Jupiter changes position every night. It's not like you have to wait a long time. You see, here's Jupiter, here are the stars one night. Next night, Jupiter's here and the stars are like this. It moves every night. So right next to Jupiter, when Galileo first observes Jupiter, there's these little stars. However, the next night, they should be way back, right? The next night, they're still there. And the next night, they're still there. And the next night, they're still there. In other words, they're clearly associated with Jupiter. There are 4 of them. We call these the Galilean moons of Jupiter, the 4 largest moons, which you can observe with a relatively modest telescope. And he notices something else very interesting. Not only these 4 objects with Jupiter, but they change position. Is it Io is the one that's closest? I think its orbit around Jupiter is like every 2 days or something. So that thing's moving, and that will change position, literally night by night. So as these objects are around Jupiter, sometimes there's 2 on each side of Jupiter. Sometimes there's 1 on one side and 3 on the other. Sometimes you only see 3 because 1 is probably either behind or in front of Jupiter. And sometimes you see all 4 off to one side. The only possible explanation of what you're observing is that these items are circling, are in orbit around Jupiter. What's the big deal about that? Extremely interesting, no doubt about that at all. But Aristotle said that everything goes directly around the Earth. This is not true. It is not true at all. Quite frankly, we have direct evidence now that there are objects out there that are not going around the Earth. In fact, they're going around Jupiter. Once again, Aristotle has another problem. Galileo Galileo also observed the moon. Now, if you go into being an amateur astronomer, and you can get telescopes now, pretty good telescopes, but for a very modest price. Quite frankly, they're fun, but about all you can see is the moon. And the moon is spectacular. Oh my goodness, you can watch the moon day in and day out. This thing is absolutely fascinating. Let's see if we can get images of what he saw. He doesn't have the ability to photograph these, of course. So he looks at this and then he draws pictures. Well, according to Aristotle, the moon, our moon, is a perfect crystalline sphere. Now, you and I look at it, we used to call these the man and the moon. What you can look up there and what you're seeing is actually lava fields. But what actually you're seeing are lava fields. But even with my eyeballs, I can look up there and see that obviously it's not a perfect crystalline sphere. It's round, but it's not crystalline. Well, what would Aristotle say about this? Well, it is perfectly crystalline. You just don't see it right. Well, every time I look at it, it looks the same way. When Galileo looks at this, and when you're viewing the moon, unless you want to have your eyes burned out, don't look at it during full moon. It's very, very helpful when you look at it at the phases of the moon. So you don't have all that brightness in your eye, but you also can see along the edge where the shadow is. I guess this is a good example right here of a crescent moon. When you can look along the shadow of the moon, you do get a very clear indication of the kinds of things you can see. The full moon is just too bright and there are no shadows, so you can't see the features. Well, Galileo watches this. Oh my goodness. I mean, I think I'm heroic if I go out for a little while and look at the moon. He would spend all night. Oh my God, he's just totally fascinated by this. As you know, the moon rotates around the Earth in 28 days. So day by day, it shifts somewhat. Well, Galileo watches it all night long. And he watched it long enough that he can see a small shift in the shadow. My goodness, this guy is really dedicated. Any event, he draws pictures of what he sees. He publishes them. And along the shadow, he's seeing mountains. And he's seeing craters, meteor impact craters, you and I know, along the shadow. And it shifts from time to time, so he draws various images. Clearly, the moon is not a perfect crystalline sphere. He looks at Saturn and he sees, well, Saturn is kind of weird to him. It's got ears. Rather than being round like Mars and Jupiter and the moon, it's a little bit oval. He doesn't know what to make of it. He keeps cleaning his lenses, thinking there's something wrong with them. Finally, he decides Saturn's got ears. What else can he decide? It's later in the century, in more advanced telescopes, where other astronomers finally decide that it has rings. Well, he notices that Venus has phases. Venus never goes across us like this, as do the other planets. Venus kind of comes up, and we call it the morning star sometime, comes up, goes down in the east. Sometimes we call it the evening star, comes up and goes down in the west. It's very bright. He notices as he looks at it that it also has phases like the moon. Now, so we have, according to Copernicus and Galileo, you have the Earth right here. You have, you have the sun right here. You have the Earth here. And the reason why you have phases of Venus is that Venus is closer to the sun than we are. So on our angle, as it faces the sun, we will find that it will have phases, which also demonstrates it's not going around us. It's clearly going around the sun. Can we say Aristotle just fell on the floor? There's not much left there. Let's pick on Aristotle a little bit more while I'm on it. Galileo discovered sunspots. Where it's not perfect crystalline sphere, it's got blemishes, it's got sunspots. Well, he didn't look at it directly. You look at the sun directly in a telescope and you're blind just like that. Now, he went blind later, and maybe his observations didn't help him any in that process. It might have sped it up. But what he would do, and I wouldn't recommend looking at the sun at all. But you could actually aim your telescope at the sun, and he has the light come through, and he catches that on a piece of paper. So he gets the image of the sun down here without destroying his eyesight, and he sees sunspots. Wow. Notice I haven't mentioned Mercury. He never saw Mercury. I've never seen Mercury. Oh, I'm an astronomy buff. I take the astronomy magazine. Every month it says, if you want to see Mercury, 5 minutes after sunset on this date, it will be right there, several degrees above the horizon. I live in Utah. We have mountains. I swear there's always a mountain. If it's not a mountain, there's a mountain and a cloud. So I've never seen it. I'm hopeful. I keep trying. Will it change my life to see a little dot of light out there? Probably not, but I still want to see it. Since Galileo believes in Copernicus, that we are in fact revolving around the sun, and the earth is revolving on its axis, people come up with a very interesting observation. Well, Galileo, if this is correct, and we know from measurements, we talked about this earlier in the class, roughly the circumference of the earth, about 25,000 miles. If you have the earth making a day at the equator, 24 hours, in other words, you're going about 1,000 miles an hour. Whoa! Walk outside, man, it doesn't look like I'm going 1,000 miles an hour around here. It gets even more odd, because if that's true, we're going around the sun. How fast are we going around the sun? Eratosthenes gave us a measurement of the distance of the earth to the sun. It happened to be fairly accurate. They didn't know at this time frame. They're not exactly sure what the distance is. They know it's a very, very long ways away. Using simple mathematics, I should call it geometry, you have if you know the radius of a distance from the earth to the sun, you know that. You just simply multiply by pi, and you simply have now, no, it's radius squared. Anyway, you simply multiply it out. You have a pretty good idea as to the orbit of the earth. For us to be going around for us to be going around the sun, we have to be moving about 67,000 miles an hour? 1,000 miles an hour this way, 67,000 miles an hour this way. People are saying, look, Galileo, come on, man. Can you possibly go outside and look around and tell me that we're moving like that? Galileo came back with this. He said, okay, let's be theoretical. Let's get a horse. Now, that's the fastest way, unless you're jumping off a building. That's the fastest way you can move as a human being on Earth at that time frame, is on a horse that's running or galloping. Let's say you're running if you're on a horse, and the horse is going this direction. I'm not sure. In sprint speed, horses can run over 20 miles an hour, can they not? You can correct me on that later if you know better than I do. Nonetheless, the horse is sprinting, and you have an object, a weight in your hand, and you drop it. The horse is going like this. Does the object go plunk? Does it just go plunk, fall down? Or does the object continue to go, get over here, with momentum down and hit the ground like this? Now, clearly, this is what happens. So the weight keeps on going with the same direction and velocity, at least initially, of the horse, where you're going. His argument is this: we are going with the object. If I walked outside and got hit by 1,000-mile-an-hour winds, I would be in big trouble. But since I'm going with the object, the air is going with the object, I don't have that problem. Galileo had knocked Aristotle on his fanny. He had simply said Aristotle is incorrect. Well, the difficulty with this is the church, the Catholic Church, had bought into Aristotle. Now, the Catholic Church, as you know, is very, very old. When the Catholic Church was established, way, way back during Roman times, the end-all and be-all of knowledge was Aristotle. This isn't really church doctrine, is it? But to be avant-garde up with what's happening intellectually and scientifically. The church does say we are following Aristotle. Over time, people actually do criticize you, and you put your soul in jeopardy to criticize Aristotle. Galileo continues to publish. The Vatican, the Pope says, we want you not to do this anymore. Well, Galileo says, you're wrong. And actually, they admit, yeah, we probably are wrong. The evidence is becoming quite heavy. Now, there are ways that the church can handle this. One of which they can say, well, Aristotle was a theory, and later on they can say, well, it was bought into, and see, it takes a little while. Just rather than saying Aristotle's wrong, you can actually ease into this by, shall we say, in slow measures, making Aristotle look like the erroneous person that he is, without embarrassing the church. But Galileo wants to go fast. He says, no, I want to keep publishing. The church finally says, look, we are going to hurt you unless you shut up. He will not shut up. He's going to keep on publishing. Finally, the church loses patience. They come down on him. He's brought in front of the Inquisition. He's questioned. Can we say it was handled improperly? I believe so, even by church standards. It was quite brutal. This man, who happened to be correct, was forced to publicly recant. I mean, he's an elderly man by this time frame. I mean, to become a martyr and get yourself tortured, maybe even killed for his ideas, I'm sorry, are just really beyond anything he wants to do. But can we say he actually, though he's not killed for this, he does become a martyr? And even though a martyr for science, even though he's not physically punished, he did make a public recantation. But he's actually put into house arrest for the remainder of his life. He goes and lives in an Italian city called Siena, where they watch him, so he won't be doing anything that's embarrassing to them. Well, his impact on science is really quite dramatic. Can we say a more important person, actually, to bring science really up to the modern time frame is Isaac Newton? Oh, there's speculation. These are fun. They don't mean anything. Galileo was born the same year that Michelangelo died. And Isaac Newton was born the same year that Galileo died. You speculate, do you believe in transmigrations of souls? In other words, reincarnation? That Michelangelo and Galileo and Newton are exactly the same spirit in a different iteration? Well, that's fun speculation. If that were true, then where did Michelangelo's spirit come from? Who was the person who died the year he was born? And then what happened to that spirit? Is it lost, or what? Or who was born in 1727 to carry on? It's just interesting. Newton was an Englishman. It's fascinating as we look at some of these great intellectual people. Sometimes their brains are really overdeveloped in one area and not as well developed in another. If we look at Albert Einstein, for example, one of the greatest minds that's ever lived, much later in the time frame we're discussing. He couldn't remember to wear his socks. He couldn't remember to comb his hair. He's always losing his apartment keys. He can't cook his own meals. His second wife, she's more of a, I guess, as much a maid as she was a wife. This guy really is lacking in certain aspects of functioning in the world. But he has this enormous brain on the other side. We hear stories about Isaac Newton. Some might even be true. A lot of them are probably exaggerated. My favorite, and you take it for what it's worth. It could be true, it could not be true. He liked cats. And then and he has two cats, this big cat and little cat. And he wants the big, so the cats can get in out. So he doesn't have to let them in and out by opening the door. So he has a hole in the door, so the cats can get in and out. And he has a hole for the big cat. He has a hole for the little cat. not realizing that perhaps both the cats could use the big hole. Good story. Nonetheless, Newton actually becomes the end all and be all is not the correct term, but he takes the information that has been presented and he puts it into a more logical theory. See, Galileo can tell you that things fall, but he can't tell you in what manner they act and why they fall. Newton's important in a lot of areas. He invents the reflecting telescope. The reflecting telescope is different than what we tend to call the optical telescope, where you have an objective lens up here. You see, glass can only be so heavy and so thick before its own weight starts to warp the image. So having an optical lens out there, it can only be so large, it can only capture so much light. Newton takes the same principle and actually makes it into a mirror, puts the mirror in the back so the actual tube itself can support the structure and the glass doesn't have to be that thick. Now the images are inverted. They'll come upside down because of the mirror effect, but you can get a lot bigger telescopes because of this. He likes light. Unfortunately, we don't really know what light is. Years ago, remember I wasn't in the high school physics class. We didn't talk about this. My brother, mathematician / physicist, he was telling us that, and he's older than I am, so his memory goes way back, that there's got to be a young, brilliant physicist out there that will eventually tell us what light is. He has to be young because when you get old and you've been taught so many things, it's hard for you to break and rethink it. Well, that hasn't happened yet. In any event, Newton tried to understand light. Let's look at Newton. He got what we call a prism. Maybe I ought to look up prism rather than light. This works fairly well. You take a prism. Prism is just a triangular piece of glass. And the white light, in other words, the light coming from the sun, hits the prism. And because the light has to go through a different thickness of glass, that it will break into its constituent parts. In other words, it's kind of dramatic, it's kind of pretty. The white light comes in, it goes to the prism, and breaks into light. So light, in this sense, is acting like a wave. And at different wavelengths, it has different colors. He plays with this quite a bit. He actually has light that comes into a prism, is broken into its colors. And then he has another prism on the other side. So the light comes in, breaks the light into color. It comes into this other prism, and it brings it back down into white light again. So he writes a book about light, one of our best understandings. One of the missed opportunities, we would say, about this is that he never observed what we call absorption lines. Well, it's not working very well. You see, let's go back to his spectrum. Okay, you can see his spectrum right here. If he had a darker room or a smaller piece of light, a more narrow piece of light, he might have observed something within this spectrum, black lines. We call these absorption lines. Many years ago, before absorption lines were actually examined and explained, there were people that would look up at the stars saying, we will never, ever know what they're made out of. Well, absorption lines can tell you this. You see, light goes through matter, and the matter absorbs it at certain wavelengths. If you sent light through helium, for example, it would absorb the light at this wavelength. Went through oxygen, it would absorb this light at this wavelength. So if you take light from a star and put it through a prism, on the basis of the absorption lines, you can tell what it's made out of. I was really disappointed. I wanted life on Mars when I was a kid. Oh, come on, man. Let's have life on Mars. And then, of course, the astronomers had measured light coming from Mars, sent it through a prism, and found out there's practically no oxygen there at all. Well, life as we know it's got to have oxygen. It's got to produce oxygen. So I'm going, well, I hope there's life up there anyway. Well, we haven't found it yet. I'm still hopeful to find some kind of bacteria up there. What Newton would have made of this, we really don't know. But he didn't observe it. Now, he's doing such advanced observations that he finds that mathematics, at least mathematics that was available at that time frame, are inadequate. So he invented calculus. My knowledge of mathematics never went to calculus. My goodness, I never got close to that. Geometry, high school algebra, it's about as far as I went. My brother, I've already mentioned him, the mathematician, he graduated in math. He says he hates Isaac Newton. I said, well, why? Because calculus is so very hard. Well, I think if Newton hadn't invented, there's other people that are working on it about the same time. Man in Germany called Leibniz would have probably come up with this as well. But nonetheless, it is absolutely stunning that we have somebody who invents another form of mathematics. Well, we remember him for other reasons as well, one of which is the law of universal gravitation. I know you're familiar with the story. It probably originated with him. I'm not sure. I mean, everybody's observed apple trees. Everybody's observed an apple falling from the tree. Some people say, oh, well, maybe it hit him on the head. Well, I've been hit on the head with apples. Used to go pick apples in the orchard. You bonked once in a while. Of course, everybody who's been underneath an apple tree has been hit on the head with them. But what Newton is saying is if you see something fall, including an apple from a tree, why is it falling? Let's go back to antiquity. And let's say we're in antiquity and you shoot an arrow into the air and it falls to earth. Well, why? Well, look at the constituents. Look at the parts of the arrow. The shaft is made out of wood. Where does wood come from? It comes from trees. Where do trees come from? Well, they come from the earth. They get their nutrients from the earth, goes into the wood, and it goes into the shaft of the arrow. Since the item originally originated in the earth, does it want to go home? I mean, even the tip might be made out of bone. It might be made out of metal. It's made out of metal. It comes from the earth. It's made out of bone. Well, the bone came from the animal, and the animal ate the plant. The plant came from the earth. So the item wants to go home. Can you say that makes some sense logically? Well, Newton is arguing for universal gravitation. Gravitation is it's a function. It's not exactly the same thing as mass, but it functions in mass. In other words, anything that has weight, let's go back to my silly old blue hand grenade here. This has mass, has more mass than my pen. Therefore, it has more gravity. Of course, the largest object around, in fact, is the Earth. According to Newton, gravity attracts, all gravity attracts objects. So you got gravity on this side of the Earth, gravity on that side of the Earth that attracts objects on top of the Earth. However, Newton said this, look, you take all of this and you distill it from the gravity here, the gravity here, the gravity here, the gravity here. And it's as though the mass of the Earth is at the center. That works fairly well. And he weighed, I don't know, 150 pounds, whatever he weighed. He says, I'm an object, I'm standing on the surface of the Earth. And the center of mass is, what, about 4,000 miles away. On the basis of that, I can calculate what the mass of the Earth would have to be in order to attract an object on the surface that weighs that much. And he comes up with this very, very large number, the mass of the Earth. That's quite remarkable. He says everything in space, everything that has mass, has gravity. This includes the sun, it includes the moon, it includes all celestial objects. And it attracts other objects on the basis of its mass and distance. He wrote a book called Principia. It's in Latin, of course. Essentially, the full title is Mathematical Principles, where he thoroughly discusses the attraction of bodies and gravitation. As brilliant as this is, and this is one of the great important works in the entire history of physics, but we still don't know what gravity is. If apparently it goes to speed of light, it multiplies itself out. If I have my hand grenade here and I have a pen, that these items, I'm measuring gravity over here, that these items would actually, maybe I better do it this way. The gravity, the mass of the pen goes through the gravity, or shall I say combines with the gravity of the hand grenade and goes over to be measured as both masses, not just one. So the one doesn't block the other one out. Now, you are very familiar with Albert Einstein. Albert Einstein actually says that mass and gravity are actually a warp in space-time. While Newton will argue when you drop an apple on the ground, it goes to the center of the mass. It's trying to, only the trouble is the Earth is in the way. That's why it doesn't go right down to the middle, but it stops at the ground. Einstein argues that it's a warp in space-time. And when an object falls to the center, or toward the center of the Earth, it's actually trying to take the shortest route across this warp in space-time. Okay. Be that as it may, and Einstein is right in many respects, you and I have global positioning systems. If they did not account for the warp in space-time, our global positioning systems would be off by several hundred feet. We cannot argue that it doesn't operate that way. But in reality, Newton's ideas do give us a very, very good explanation as to the nature of the universe, as was understood then. Well, let's move away from science a little bit. Please indulge me. I'm going to look at my time. I got plenty of time. Well, let's look at another intellectual, shall we say, accomplishment this time frame. And we can call that the Enlightenment. Can we say the ideas are reasonable, rational, quantifiable, all these very nice things which we are seeing in science, if you try to apply that to the human community, and we can perhaps call this social science if you would like, in other words, being reasonable and rational as far as human beings are concerned. And that is reason and methods of science leading to social science. I'm going to make a big deal over the Enlightenment. Enlightenment is not more important than science, but can we say that the Enlightenment, using scientific method, among other things, does give us a better understanding of the human community. I'm going to make another assumption, that the Enlightenment actually creates the mental mindset of the modern world. Yes, there has been attacks on Christianity. Yes, we have now not one form of Christianity, we have three: Catholic, Lutheran, and Calvinist. But to say that we've actually gone away from the influence of accepting authorities is not quite complete until you get to science and get the Enlightenment. As I'm going to explain the various aspects of the Enlightenment, I'm going to ask you to look and say, are these not our basic assumptions of society even today? And I'm going to say, therefore, that we are children of the Enlightenment. The Enlightenment influences so many of our basic assumptions, even as I speak. Okay, reasonable, rational, look at human communities. Basic assumptions. Progress. Do we believe in progress? Progress is around us all the time. Progress in technology, progress in society. I'm older than you are. I can see progress in society. I see progress in women's rights. I can see progress in voting rights for minorities, including African Americans. I have seen progress. In fact, I expect progress. As I read newspapers, as I look at magazines, I see evidence all the time that we are trying to make progress by improving our institutions and by improving our society. So to me, it's just a given. How else could you think of it? Back before the Enlightenment, there were important thinkers who did not believe in progress. Some quotes from this time frame. Was it Pope's epigrams? English thinker. He was saying that little knowledge is a dangerous thing. You're familiar with that. He said, that which is best. What? Look around, 300 years ago. Look around at society, that which is best. It has to be. Leibniz, I already mentioned him just in passing. He was another brilliant physicist, brilliant mathematician, doing similar work as Newton at a similar length of time. And unfortunately, Newton, however, being better. But Leibniz said we live in the best of all possible worlds. A little bit like saying that which is best, we live in the best of all possible worlds. In other words, they don't believe in progress. Could you imagine what it'd be like 300 years ago in England, Germany, wherever you happen to live? Oh my goodness, the crime rates are terribly high. I mean, there's social injustice all over the place. People that are wealthy have more influence in the courts. We have disease. We have premature death. We don't even have a germ theory of disease. I mean, the enormous amount of progress we've made in this last several centuries would make this time frame look very, very challenging. But they don't believe in progress. Well, the Enlightenment does. We can examine ourselves. We can be more careful. We can make things better. In other words, we can make a better society. Here it is right there. We can make society better by being more reasonable, more rational, and giving people more opportunities. Another basic assumption is that people are good. If you believe in a better society, it's very helpful if you believe that people are good, so people may be improved. You do things right, people by their nature will be able to benefit from this, and you have better people and better society. If you believe that people are completely degraded, if you believe that people cannot choose to do good, then your efforts are frustrated, are they not? So this is an important assumption. How do we improve people? There's more than one way. Can you say education improves people? Do we believe this today? You're at an institution of higher learning. I know a lot of you are trying to improve yourself. Hopefully, we're helping in that process. That education makes you more able to deal with society, more able to understand society, more able to understand the potential of human beings, to give you knowledge and perspective to help you make progress. We make better societies through an educational process. We believe this very, very strongly. Another issue is toleration on religion. I'm not going to say that everybody in the Enlightenment believes the same thing. We have numerous Enlightenment thinkers, and some of them literally hate all kinds of religion. You name it. It's all superstition. It's all brutal. I'm not denying that those people exist. They're clearly out there. Can we say most of the Enlightenment thinkers say, well, and they might even say, if you're dumb enough to believe in religion, we might as well tolerate you for what you believe. It was not uncommon before the Enlightenment for people to be persecuted for their beliefs. I made a big deal of the witch craze. That is an example of people being persecuted for being different. Or maybe they're just a little bit different in their beliefs. Toleration. Do we believe that in our modern society? We have numerous religions in the modern world. We have numerous forms of practices in the modern world. And in reality, why would one group want to pick on somebody else? As long as you don't bother me and I don't bother you, let's tolerate each other. It's a very important assumption as we go into the modern world. Let's take a look at some of the Enlightenment thinkers. Let's look at John Locke. We've already met him, haven't we? Yeah, we met him. Great guy. This guy writes the second treatise on government. And remember, I gave you the basic assumptions, which virtually all modern representative governments use as the basis of their rationale for their existence. Very important man. But he's also important in the Enlightenment for some other reasons. Now, I'm not going to say that he's the first person who ever came up with these ideas, but I am going to say that his writing, his prestige, does tend to popularize them a little bit more. Okay, Essay Concerning Human Understanding, published in 1690. That's the same year, is it not? The same year as when he published the Second Treatise on Government. He probably wrote this earlier as well. Well, Essay Concerning Human Understanding, it's a philosophical argument, which he's saying that why are some people different? You see, going back to some people who are believing in the divine right of kings, that God has chosen you, God has made this ability, you are reigning because of the will of God, and therefore we can't fight against the king because we're fighting against the will of God. But in reality, why are people different? Why do people have different stations in society? How come people can achieve more, one person to another? And essentially, he's arguing that it is how you are, you and I would call it acculturation, how you have education, how you are taught. His argument is basically this, that children are actually born as a clean slate, the tabula rasa. Actually, I've read this. I'd heard that he called it tabula rasa, the clean slate. I never saw the terms in the essay. I'll have to read it again and see if I can find those terms. Nonetheless, if we use that term or not, children are born with a clean slate. Children are born, and how we have differences in society is by how they are taught. According to his idea, if you have a blacksmith's son and you took that boy or girl, girls aren't sons, a blacksmith's child, and the mother might be a milkmaid, you take that child and you put them into a higher class society. Will they be dragged down by the fact that their parents had a little bit less social advantages? Conversely, if you have somebody from a wealthy family, noble family, you took that child and gave it over to a blacksmith and a milkmaid to raise, would that child be somehow more superior, more noble? He's saying that's not the case. We actually do have some logic that he could draw on. People have a tendency to like kids. Sometimes older people have a tendency to like kids even more. Not everybody, but a lot of people do. You're young people, I'm sure you have these experiences. This kind of happened to me when I was young. Older people would say, well, young man, how are you doing? Well, fine, thank you for asking. Older people have a tendency to like young people. And sometimes people like children. They like children. They like the play of children. Children can be awfully cute, can't they? They say cute little things, they can be very affectionate. They crawl up on your lap and they hug you. And wealthy people, this is not uncommon, it does happen. Wealthy people back this time frame say, well, my grandkids, maybe they didn't have children, or the grandkids are away, or maybe they don't have any grandkids. And they'll bring in a waif, sometimes an orphan, sometimes a family just can't afford to raise the child, and they're willing to give the child over to a wealthy family to raise them. And what are those children like as they're being raised? Now, they know they're not from the family. They know they're not going to inherit all this money, but they're raised with the same kind of assumptions, the same kind of clothing. They might be just as superficial and worthless as everybody else in their social class. Many years later, this is the 19th century, Charles Dickens wrote a novel called Great Expectations, in which, and I believe his father was a blacksmith. A wealthy benefactor took that child and gave him all kinds of money. And goes into London and he learns how to fence and he has an education and becomes a worthless, superficial person. Not anything like a blacksmith. See, advantages. You take a child, you give them advantages, and in reality, they will progress. I'm not a good psychiatrist or a sociologist. In fact, I'm a novice in both cases. But I'm going to argue that he's right, except with perhaps one caveat. As we as children come into this world, we do have the ability to learn. I mean, you can take little babies and put them up, and they'll kind of make sounds like, it's kind of make movements like they're walking. You don't have to teach a child to speak. You just talk around the child, and pretty soon that child is going to be, we call it baby talk and babble. And after a while, that child's going to know how to speak. Because the child clearly does have the ability. It has the ability to learn how to speak. So I think that's innate. But his assumption is extremely good, that we need education, we need opportunity to improve people. Let's talk a little bit philosophically about some of the major ideas. A deism. Well, remember in discussing toleration up here, and some people are crass atheists. They're not large in number, but they are part of the Enlightenment. I don't believe in anything. There's a problem that a lot of the Enlightenment thinkers have. If you deny the existence of deity, if you deny the existence of a creator, if you deny the existence of a God, then how do you explain reality? How do you explain existence? How do you explain the fact that I exist, the fact that there are societies, the fact that there are buildings? How on earth can we explain this unless it came from something? It's way too early to talk about Darwin's origin of species and the evolution of biological entities. But this is a conundrum for a lot of these people. Do we not want to have a logical assumption? Many of the Enlightenment thinkers come up with the idea of deism. Deism is that there was a God, maybe there still is, but a creator, a force, a substance, an ability, a creator that created the world. And this entity created the world, created everything in it. The entity created, or shall I say, made physical laws. There are basic laws, let's go back to Isaac Newton. There are laws that how the world sure seems to operate. Universal gravitation, falling bodies, all these kind of things. God created this, set up a paradigm of using all the physical laws, and then left. Bingo. Doesn't care anything at all. He's not interested anymore in us at all. Looks down there and says, good enough, go someplace else. Sometimes in deism, we look at God as the master watchmaker. Once again, clocks, watches being the most advanced technology at the time frame. This entity makes the physical universe like a master watchmaker. And the fact that it left, or he, she, or it, whatever left, means that there is no interaction anymore with deity and human beings. One of our definition of miracles is that obviously deity causes this to happen. They're saying there's no such thing as a miracle. Miracles, shall we say, are occurrences that defy physical laws. Physical laws are immutable. They do not change. There are no miracles because God doesn't care about us at all. Prayers mean nothing. He doesn't care. Not even paying attention. Goes away. So therefore there are no miracles. There's no interaction with God. God is just a reasonable hypothesis to explain existence. Let's go back to the watchmaker. According to this idea, you create a mechanism and go away. Make a watchmaker. Well, a comeback on this, which I find to be somewhat amusing, is that people say, well, yeah, you make a watch, you wind it up, and you walk away. Well, what happens to that watch? It's going to run down, is it not? And maybe it's going to have to be cleaned, it's got to have repairs. So does not the deity have to come back from time to time to clean the watch and to wind it up again? Okay. Another argument that God does come back. But that argument still says that God is still working within the same physical premises. And there are still no such thing as miracles. Let's talk about some of the more important of the Enlightenment thinkers. Let's talk about Voltaire. I've already mentioned Voltaire ever so briefly, virtually in passing. Voltaire was a Frenchman, and remember I said that when Louis XIV dies in 1715, what would Voltaire be? About 21 years of age. And he is one of our sources when he's looking around France when Louis dies to see the celebrations. Everybody's so happy in the bonfires. Wow, at least he's dead. At least we got hope for something better. He has an interesting biography. He's a Frenchman. And he's a very clever man. He likes to insult people by implication. He doesn't like a lot of people from the upper classes. At one time, a wealthy man took offense to some of the things that Voltaire said about him. So the wealthy man wants to give Voltaire a lesson. And he hires a bunch of thugs to beat him up. Make sure that this wealthy man gets his money's worth. He actually follows the thugs in a coach. And when they drag Voltaire out on the street, the wealthy man gives them information on exactly how to beat him. You could imagine how awful of a situation this would be, how humiliating a situation this would be. Voltaire, his entire life, would be extremely concerned about people who have arbitrary power, about people who can push their weight around, about people that are being immoral. Did it really necessitate him being beaten up, the fact that a man took offense in what he said? Voltaire spent actually some time in the Bastille, the famous French prison, which we're going to talk about when we discuss the French Revolution, how in 1789 the mob took the Bastille and destroyed it. Well, it can be a pretty severe prison. Voltaire still had books. He wasn't there but a number of months. He actually also got the idea that being in France was not the best idea, so he went over to England. He likes England. Oh, goodness. He thinks it's freer in expression. He likes the intellectuals that's been there. And he said he has his own personal Trinity, not Father and Son and the Holy Spirit. His Trinity is Francis Bacon. His Trinity is John Locke. His Trinity is Isaac Newton. Can he say, therefore, that he's borrowing a lot of the ideas that have been popularized in England? Yeah, he does. Of course, he goes back to France and spends the rest of his life, after spending a few years in England, much of his life in France and Germany and Switzerland. So he does a lot of traveling around. He is very good in criticizing society. He's a very clever man. Quite frankly, he is funny. Perhaps his best remembered work is a novel called Candide. It is a brilliant satire on society of his age. He takes shots at all kinds of institutions. It's a total farce, very amusing. There was a time in a class like this when I would require the students to read this and to analyze this like in a book review. The difficulty with that is I think you have to bring a certain level of understanding of the society at the time frame in order to understand the humor. I highly recommend that you read this, but you might want to have a little bit better understanding of society at the time frame to understand the kinds of jokes he's making. Well, Candide, I guess that's French, largely means like candid. In other words, something that you are saying clearly, candidly. Well, Candide lives in a place in Germany. Voltaire makes fun of the long German names. As I recall, Candide is living in a castle called owned by a man by the name of Von den Trock. And it sounds like thunderstruck, some ridiculously long name. Well, Candide has a little bit of a problem. He he's in love with Kunigunda, fair maiden there. And the noble, Fondentok, catches Candide stealing a kiss. Well, that's too much. So he throws him out. And then Candide goes on all these adventures. He goes down to Bulgaria and the Bulgarian army. He gets forced in the Bulgarian army where the discipline is severe and he's beaten for turning left and right. Turning left when he should be turning right. He finally gets away from that. He goes up to Holland. He's starving. He turns to a Dutch minister, Protestant, turns to a Dutch minister. I'm starving. Would you please help me? And the minister says, oh, do you believe in the Holy Spirit and the Trinity, separate but equal? And Candide says, no, I don't understand that. Will you help me? The guy says, I'm sorry. Your belief system's wrong. I can do nothing morally for you. See, he's taking shots. He's taking heavy shots. Well, eventually Candide gets in a boat and he goes across the Atlantic. There's a mythical area. Can I get Voltaire for us up here? There's a mythical area does not exist, which is called El Dorado. El Dorado is actually, if we were having a huge discussion on the age of exploration, unfortunately we only had time to be superficial. But there is a myth that a lot of Europeans believe that there in fact is an area that is so wealthy that the streets are paved with gold. Maybe it's in the Americas. Maybe we can find it. Whoa. Well, it doesn't exist. But Voltaire says this is the ideal society. So he has a pretty heavy criticism of society by saying, oh, there is a society here where you can be reasonable and rational. Yes, the streets are paved with gold. And he asked the people there, Candide asked the people there, why do you pave the streets with gold? He says, it's a pretty metal. We're certainly not going to kill anybody over to go to war over it. You see, reasonable, rational society, you need to take care of yourself. You need to improve yourself. After describing this very nice society, Voltaire has Candide go back to Europe and eventually gets back to Kunigunda, which is kind of nice, except by this time she's an old toothless hag. I'm not sure what Voltaire is saying by the decline of Kunigunda. Maybe he's saying that a lot of times when we're looking in the wrong direction for enlightenment, in reality, we need to, when we examine it carefully, we'll find out that it's not exactly what we want it to be. That's a possible interpretation. Voltaire is anti-religion. He takes shots at the Catholic Church, the Protestant Church. He takes shots at Judaism. He also takes shots at virtually everybody. We can call him anti-Semitic. That's probably accurate. But on the other hand, he's criticizing virtually every religion, not just one faith. He uses a very, very unfortunate event to push for his ideas that religion is bad. The religion holds us back. The religion is, quite frankly, keeping us from progress. One of his contemporaries, Immanuel Kant, a German philosopher, made a big statement about this in an essay called What is Enlightenment? He said that people, societies, have got to overcome their perennial immaturity to think things for themselves. Voltaire believes this kind of thing, and he makes a big deal about the Lisbon earthquake. One of the most important Christian holidays and the entire calendar is November 1st. When we're discussing Martin Luther and the 95 Theses, I made a big deal about this. November 1st is a very important day. All Saints' Day, All Souls' Day. So, in Lisbon, one of the most religious and Catholic areas anywhere in Europe, at about 10 o'clock in the morning, on one of the most holy days, when many hundreds of people, thousands of people, are in the churches to hear Mass and celebrate the Lord and His mercy and the saints, the earthquake strikes, and it's quite vicious. The Churches are not properly set up for this. They cannot sway, so they crumble. People are in churches, worshiping the Lord, doing the highest service for Him, and then the buildings collapse on them. Hundreds of people are killed. Very disturbingly, there are women holding babies in their hands that are crushed to death, and the babies are killed as well. Now, Voltaire is going to say, whoa, where's God? Where's the merciful God? Where are miracles? Would not this be a time of blessing, not a time of destruction? That's one of his arguments. Oh, I wanted to say one other thing about Candide before I got off the novel entirely. Initially, Voltaire didn't want to take the heat for it because there's a lot of criticism, a lot of institutions. So he published it anonymously. Then his friends and followers come back and say, oh, by the way, we really enjoyed your book. He says, I didn't write it. Yeah, they say, yeah, who wrote it? Obviously, nobody else could have written it. So his ability, his skills, made it sure that he had a little more hard time being anonymous. Well, Louis XV, remember, he's the great-grandson of Louis XIV, and he's ruling in France. In all fairness to him, even though he's not a very bright guy, he's not nearly has such a bad track record of hurting people as did his great-grandfather. However, he's raised Catholic, he believes in Catholicism. And there are these attacks. Notice we have this attack from Voltaire and many others, attack on religion. And finally, Louis XV in 1759 puts out an edict saying that if anybody criticizes the church again, they will be subject to the punishments under the law. We can imply very clearly that maybe you're going to be incarcerated, fined, maybe even killed. He's not going to put up with this anymore. You're going to have to shut up or I'm going to hurt you. Now remember, he's a weak man. He probably doesn't, well, he doesn't enforce this, is the bottom line. However, let's look at somebody like Voltaire and many other thinkers this time frame. Are you going to use this as you're going to cow you into shutting up? No, actually, it's like throwing down the gauntlet. The king has thrown down the gauntlet, and now we as Enlightenment thinkers are going to take up the challenge. Rather than shut up, this really gets them going. My goodness. Tracts, pamphlets, letters. They come out in large numbers. This is a sustained attack, and it goes on for years. Voltaire had a similar situation, a similar influence, as did Erasmus a couple of centuries earlier. Voltaire is so popular, and he has this enormous correspondence, huge, writing to everybody. Everybody's writing to him. Same kind of thing we hear about with Erasmus. People have an idea, they send it to Voltaire. And Voltaire either likes the idea or doesn't like the idea. Voltaire says, well, you can improve it by this manner, or maybe you ought to go in a completely different direction. He is largely on the pulse of the intellectual function of Europe for many years. And he is leading the attack along with others. He starts using this as a catchphrase. Écraser l'enfant, crush the infamy, or crush the infamous thing. He uses that in his correspondence. A lot of times he'll sign his name Voltaire, Écraser l'enfant, or Écraser l'enfant Voltaire. The discussion might not even be directly related to religion, but he keeps on pushing that in. There are times when he doesn't even sign his letters with his name. He just signs it, Écraser l'enfant. Let's take down the church. He means in this case specifically the Catholic Church. This has enormous intellectual impact on the history of Europe. I'm not going to say there's attacks earlier on, and I'm not going to say there aren't attacks later on as well. But I am going to say this is one of the most important and pervasive attacks by intellectuals on religion. Can we say he tends to break things down? Can we say that religion is put back on its heels? It has a harder and harder time defending itself. Can we say that, going back to Kant, we need to break our immaturity? Maybe we need to break the nature of our dependence on religion, because there's aspects of religion which are detrimental to the intellect and sometimes detrimental to morality. I do admire Voltaire, and for a lot of reasons. His attack on religion probably was necessary to make religion more moral, more reasonable. Did he go too far? Perhaps he did. But one of the main reasons why I admire Voltaire, and sometimes we call him the conscience of Europe, this man takes on all kinds of causes, moral causes, social causes, for decades. One book I read on him said 100 causes in a period of, let's get the entire quote over here, in a period of many decades. You've heard the story many times, that the pen is mightier than the sword. This guy does not lead armies, but by darn, he is influential. There are a few French Protestants that are left alive, and they're living in the Alps on the borders of France. And a young man dies. He might have committed suicide, but the accusation was his father killed him because he was going to convert from Protestantism to Catholicism. So this father is tortured, and we try to worry about the nature of the confessions. You see, Voltaire comes down on this: you cannot torture people. What you're going to come up with is fallacious information. You've got to back off. You've got to be able to use proper jurisprudence. Let me bounce back a little bit. I don't know how many of you saw the movie Braveheart. If it's a guy flick, if you're a guy, you'll probably enjoy it a lot more than women will. Those of you who have seen it, I believe it came from the 1990s, hasn't been around for a while, but there is a scene as to when William Wallace was executed. He was hanged, drawn, and quartered. The motion picture didn't show you what was happening, but it essentially showed you what was going to happen. This man was spread-eagled. He was eviscerated. They cut open his stomach. They pulled out his innards, his stomach, his intestines. He's still alive. They burned them. He got to feel it before they finally cut his head off and killed him. And they dismembered his body, put his arms and legs, sent him to different places. They put his head on a pike, a high pole, in front of the Tower of London, where it sat and rotted. In the 1740s, this is hundreds of years after the execution of William Wallace, the Scots revolted, 1745, 1746, very much within the lifetime of Voltaire. And there were still Scots that were captured by the British, that were hanged, drawn, and quartered in a very vicious form of torturing somebody to death. And Voltaire said, you cannot do this. You're going to have to deal with my pamphlets. You're going to have to deal with everything I say. You cannot do this anymore. Can we say, because he's leading this charge, among others, that we do see a disappearance of these kinds of things? As bloody it is to us when we talk about the French Revolution, the guillotine that cuts people's heads off was actually a much, 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 much more merciful way of killing people than had ever gone on before. My goodness, his impact is literally enormous. When I was at the Catholic University in Washington, D.C., I went to a class where a Catholic priest was there, and he made a comment in class. And he looked at the story of Adam and Eve, and he called it an allegory. Not like it really happens, allegory, where it helps us understand the teachings of the Lord. If he had said that a couple of years ago, that would have got him killed. A couple of hundred years ago, that would have got him killed. When we look at a reasonable, rational society, thank you, Voltaire. When we look about the decline of torture and the rise of proper jurisprudence. Thank you, Voltaire. When you look at a reasonable, rational, moral religion. Thank you, Voltaire. If we ever get to the point where we do not honor the kind of contributions that were made, I firmly believe that we become unworthy to enjoy them. One thing that was said to Voltaire when he was doing these moral things, trying to bring justice to the world, it was said to him, "You seem to attack Christianity, yet you do the work of a Christian. You certainly do." So how much time I got left? I'd like to talk more. Got a few more minutes, so let me say a few other things about Voltaire. Voltaire is one of the greatest writers that's ever lived. All his philosophical dictionary, where he's trying to be reasonable and rational, and rather than being trying to talk about all kinds of different institutions, including the church. Well, he's one of the greatest writers that's ever lived. He wrote biographies. Some of our best work, our understanding of Louis XIV, was because Voltaire went around and interviewed like 200 people that were in the court and knew him. He wrote biographies of the kings of Sweden. I mean, as contributing and writing brilliant biographies, Voltaire is extremely good. He wrote plays. Where I talked about his novel up here, Candide, considered a brilliant piece of literature. He wrote plays, highly well received in the brilliant French theater. Actually, a lot of the literary people in France remember him as much for poetry as anything else. But you see what I said, biography, novels, poetry, drama. Has there ever been another writer that has ever mastered so many genres? Could we say that Voltaire is the greatest writer that has ever lived? Interesting. I have a good friend. We are a member of the same historical society. We get together once a year. And one time we were in Philadelphia at the same time, and we went to see a play that was based on Candide. Of course, we both enjoyed it very much. At least I did, and I think he did as well. And I had to ask him that question. He got his PhD in French literature from Harvard. And I said, is it really true that Voltaire is the greatest writer that ever lived? Without missing a beat, without even mispronouncing a word, he says, without question. One of the great minds. Get down to the next page. I have delusions of grandeur. One of my delusions was I was going to get entirely through the Enlightenment today. I don't think that's going to happen. But we're virtually out of time. I appreciate you very much. I've always enjoyed my students. I've enjoyed teaching this class, and hopefully my performance meets your standards. In the meantime, whatever you're doing, enjoy. Enjoy it twice for me. And I will record another lecture shortly so you can view that one as well. Take it easy.